Are there any questions? Is there someone about to come up with a question? All right, so this I think is a recap of what we've done so far with AC. Add another component. So we're going to do the RLC circuit. Because we did the RC series circuit, I know that because that was on the lab. And from looking at Zach's notes, we did the RC parallel circuit. Did we do the RLC series circuit?
No, we did not.
All right. So power supply. Capacitor, resistor, inductor. Oh.
What is this bottom component to the circuit?
What is this?
Yes.
Inductor. I'm thinking we actually derived the formula for inductor. Because, or at least you've seen it, because for the electromagnetic induction lab, one of the questions was, what's the inductance?
Yeah, we talked about that.
Okay. And what happens is that with the inductor, that as the current changes in the inductor, the magnetic field inside changes, and if the magnetic field inside changes, the magnetic flux changes, and the magnetic flux changes, it induces a voltage that wants to oppose the change in the flux, which creates a back current in essence. All right, so we're going to start with, I think the first question whenever you're doing a phasor diagram is there anything common to everything? So in this case, is there anything common to everything?
The current?
Yes, it's a series. So to start out with the current phasor. Now traditionally I've started with that first phasor in the first quadrant, but it seems like life's a little bit simpler if we just start it someplace else. So I'm going to start it straight up on the axis right here. And that's my current phasor. Technically it's 4 phasors in one because it's the current that's flowing out of the power supply, which is the current flowing across the capacitor, which is the current across the resistor, which is the current going through the inductor. And again, for the phasor, it's just think of an arrow that's spinning counterclockwise around the central point. All right, so now we have 4 voltage phasors to figure out what happens with them. So, what's probably the simplest of the voltage phasors?
Is it VR?
It is. And why is that simple?
Because it's pointing in the same direction
As
as IR.
absolutely. And we can always go for a stunning, absolutely spectacular visual effect here. Ooh, wow.
Oh,
All right, what's next? Three more voltage phasors to go.
VC, or
All right, so which way is VC gonna point?
it will be
Perpendicular
perpendicular,
to
yes.
It's
the,
either up or down then.
I don't know. It's upside down. Wait,
I think we can pick, can we?
No, it's pretty much set.
Oh, okay.
Think of Eli, the Iceman.
Oh, okay. Up,
Why?
because, the traditional is, counterclockwise, and we want the, wait, right?
Which one are we on right now?
VC was the one that he mentioned.
DC?
well, current should lead the voltage if we use the highest part of the acronym.
Okay, therefore,
So if this here is the current, it should point down, wait, I forgot which way is forwards and backwards.
Yeah.
Is
it's spinning around,
counterclockwise.
spinning around like this.
Right, so it would be pointing up because the current has to lead
So
the voltage.
the voltage is pointing up.
I think so.
Wait,
I think it's.
I'm getting
down.
it should be
Confused now.
pointing down because then it goes up to current.
Does the current have to lead?
Yeah, current leads.
Yeah, the current's in front of it as far as.
So if it's like this, spinning around like that, the bandage finger being the voltage.
Oh,
Current.
right. Got it. It's down.
It's down, yes,
Wait.
okay.
No, that's confusing.
Yeah, I got
That's
confused.
you.
I get it now, cause IC is pointing to the right,
Yep.
and so VC needs to be,
Current leads,
current, which is I, is leading
The voltage.
the voltage, and we're going
When he did
counterclockwise.
his hand like this, that's when it clicked for me, because it's like they stay in that same orientation, so it's the one, it has to be in front.
okay, now it makes sense. Eli the Iceman just confuses me,
Yeah.
because I
Okay.
don't know what everything stands for.
The E's are supposed to be voltage or the E and F,
Yes.
which doesn't make a lot of sense, but that's what they're for.
Engineering textbooks.
Yeah.
So,
I mean,
current,
the ICFA doesn't quite flow.
so it's like current, for the Eli part, it's voltage, inductor, current, and then current, capacitor, voltage.
Exactly.
Yes.
Okay, that's easier. I like made it so hard in my head when you first introduced it to me.
So this would be VC. And what now?
So then does that mean for the capacitor that it's straight up?
Say it again?
I said, does that mean for the capacitor that it's straight up?
That is for the capacitor.
Oh, that's what you, so then for the inductor, it's straight up.
Yes. Now, I don't, based on, I haven't given you enough information for you to know if VC or VL is bigger. Just pick one.
Pick one to be bigger.
Yeah.
Oh.
When you're just sketching down a phasor diagram without more information, you just, one of them's bigger than the other. It's ultimately, I'm gonna be squaring the difference between the two, so it doesn't really matter mathematically.
So you're saying it's inaccurate to draw them roughly the same length? It's more accurate to pick one?
Yeah, if I draw them the same length here, then the next step, it's gonna get sort of messed up a little bit. It depends on how abstract you wanna think at the moment.
Can I ask why the voltage of the, inductor's up? Is it just because it's like opposite the capacitor?
In this case, yes. I mean, how far back do you wanna go? I mean, for the inductor, voltage comes first.
Right.
So that's one of the reasons, so because current's over here, it's got a, voltage is coming first, so as they move.
I see, okay. Yeah, that makes sense.
Okay. Is that good enough, or do you want me to go deeper?
No, that makes sense.
Okay. All right, I'm missing one phasor. What phasor am I missing?
The power supply,
All right, and I know the power supply phasor's gotta be the sum of the other three. Because if I go from here to here, it's path independent which way I go. So the sum of those three voltage phasors has to add up to the power supply.
So it's gotta go this way, right?
Say it again?
It's gotta go to the right?
And kind of.
There will be definitely a right component to it.
Probably also a down component.
That's why?
Well, if you had drawn V sub C and V sub L the same length, it would just point directly.
Focus, right?
Right, so because that was a little shorter, it should point a little further down below that.
Yeah. And if I made VL longer, it would point a little bit up. Again, it would work out in the math if we had to, if we take it that far. So ultimately, let me add the two easy ones first. I'm going down more than up in my drawing at least. So this would be VL, sorry, that VC minus VL. And then I add in my voltage for the resistor. And this red arrow right here, that's pointing at a tilt, is the length would represent the magnitude of my volt power supply. So that's V, oh, no, that's VR. So what is the mathematical relationship between VR, epsilon sub naught, VL, and VC?
42.
Well, besides that,
That's a given.
what'd you say?
So that's a given.
Oh, yeah. What's the relationship, just tell me some relationship between this VR and VC minus VL? Not looking for anything really sophisticated here.
Well, I guess epsilon sub naught would equal V sub C minus V sub L, that quantity plus V sub R, because that's how we drew it.
So you're saying that if I take that length plus that length, I get that length?
No, I'm saying if you take V sub, it's literally just what we did, I'm just regurgitating. If you take V sub C and subtract V sub L from it, and then add that to V sub R, you get epsilon sub naught in this case.
Okay, how do you add them?
Like vectors.
Right.
Okay, we're getting closer.
Yeah.
If this right here is, we'll just say 3 volts, and this right here is 4 volts, what would epsilon sub naught be?
3 squared plus 4, it would be the square root of 3 squared plus 4 squared.
Yeah, Pythagorean theorem, that's the mathematical relationship that I was hoping for. So epsilon sub naught squared is equal to VR squared plus VC minus VL squared. Also goes back to my comment earlier that we're gonna end up squaring that difference anyway, so it doesn't really matter which one you subtract from which. All right, so now, ultimately, I didn't really state what we were going for, so in my mind it was clear, and some of you probably can't read my mind this morning. And what I'm trying to do is find the formula for the impedance of this particular circuit. And impedance is the sort of resistance equivalent for that particular component or circuit. So what's the relationship between, well, all my voltages and anything else? Let's narrow it down. What's the relationship between epsilon sub naught, the magnitude of my voltage from the power supply, and the impedance? And I assume, Zach, you see it based upon the way you're looking.
Yeah, well, it's, the epsilon sub naught is equal to I power supply times Z in that example, so like they're, I don't know the words that I'm looking for, but
Impedance?
yeah, it relates in.
That right there?
Yeah.
All right, this is not for this example. This stuff over here is proved regardless of my circuit.
Mhm.
Could we not still say impedance would equal epsilon sub naught over, the current of the power supply?
It's just current.
impedance change with every scenario.
Circuit, yes, that's why I don't have a formula for impedance over here,
Yeah.
other than this one relationship. But I don't have what the impedance is in terms of R, L, and C, because that will change depending upon the circuit.
But we can't play substitution with these variables with that formula to get there.
Well, yeah, well, what we're gonna do is, we are gonna say, well, that's current from the power supply times the impedance squared is equal to current across the resistor times the resistance squared plus current from across the capacitor times X sub C minus IL XL, and then that quantity squared. Now, I know current is the same, for the sake of process, I put down the subscript next to each of the currents, because it's not always, the current's not always the same in every problem. Like the last one we did, when we did the RC parallel circuit. But in this case, I know current's the same for all of them, that was established early on. I can factor I out, cancel it, because it's all the same. So what I'm left with is my impedance squared is equal to my resistance squared plus XC minus XL squared. So my impedance is the square root of R squared plus 1 over omega C minus omega L, that quantity squared. And XC is always 1 over omega C, XL is always omega L. And as explored last week, inductive reactance, well, I guess we didn't do that last week, but capacitive reactance.
Just to clarify, reactive capacitance is not a thing, right? I've caught
Reactive
myself-
capacitance is not a thing.
Okay,
Capacitive reactance.
see before R.
Questions up to here?
I had one to kind of backtrack.
Okay.
I'm still confused about why the inductance is going up. Why could it not go to the left? Or,
I mean, why is it off by 90 degrees? Or,
Why do we make inductance go up?
alright, because, alright, just going down the next level,
Yeah.
that for inductance, for inductors, the voltage comes before the current.
Okay.
Alright, you want to go deeper? Alright, because it's always by 90 degrees. The phase difference between the voltage and the power and the current for these three components,
Yeah.
ignoring the power supply, for those three components, the phases, they're either in phase or off by 90 degrees.
Okay. So, but that. Okay. So it's that in relation to, I'm still, how is that off by 90 degrees? So the inductance is, and you're referring to.
Because 90 degrees from the current, because I sub L is pointing that way,
Okay, from the current.
V sub
Okay.
L is 90 degrees off.
Okay. Gotcha, okay.
And we arbitrarily chose this as the direction for current.
Yes.
Like in theory, you could have put it elsewhere.
Yeah, because they're all spinning, so I could, take a snapshot at any time.
Okay, yeah, I'm good. Yeah.
Alright. We need to establish something that's zero. Now technically, well, I guess not technically, usually I'll set this phase right here to be zero, and I'll establish my power supply is what we're basing it all on. Which doesn't necessarily mean I have to draw my phasor so epsilon sub zero is pointing in this direction, because usually when I'm starting a problem, I don't know which direction it's gonna point in. But as far as drawing phasors go, the first phasor I draw down, I just arbitrarily pick what feels right. What's my mood today? And that's where I draw my first phasor. Out of habit, I usually pick my first spacer somewhere around there. But textbooks tend to draw it straight off to the right. Which I found ultimately a little bit easier. Questions?
Were you recommending that we set this to equal to 0, or you were just saying historically you've done that?
That's something that I would give you,
Oh, okay,
in a problem.
okay.
Or if I don't give you, to you in a problem, then I'm not asking for the full blown, give me the equation for all 8 phasors.
And what would showing us that it's equal to 0 look like? Would you just like write it down and say equals 0, or like could it be worded in such a way we have to interpret as it's equal to 0?
The potential, it could be that the initial phase of the power supply is 0,
The initial phase of the power supply
is 0.
So that's indicating that epsilon sub naught.
That's indicating that for this equation right here, because remember, these are all cosine functions of some form or another. That would mean that that's the phase right there,
The phi.
the phi, yes. One of the
Phi
reasons
would-
they chose phi is because it begins with the same sound as phase.
Oh, I remember, okay, I see what you're saying.
So phi would be 0.
Right.
Phi, yeah, that phi would be 0 for this equation,
0 degrees,
or radians, if you're cool.
okay. Got it.
Omega is typically in radians per second, so it's helpful to have phi in radians as opposed to mixing your units up in there. It's not officially wrong to have it in phi in degrees, just an extra step you have to go through when you do omega t plus phi.
Just be cool. Use rating.
Will you say that sentence one more time? The something is equal to 0, I wanted to.
The initial,
Okay, so one way I could word it is that the initial phase of the power supply is 0. I can also word it as when time is equal to 0, epsilon equals epsilon sub naught. Or when time is equal to 0, the voltage of the power supply is at a maximum.